Okay, so today we want to talk about log identities. Today is again a detour from our study of waves, but it's a detour that we need in order to be able to calculate and work with decibels for sound waves. So we're going to spend another day looking at logs, and this time we want to look at log identities. Quick reminder, when you're looking at the log of a number like 4 million, the number in front tells you that you're in the millions, or the thousands, or the hundreds. So since we're in the millions, it's 6. Since we're in the tens, it's a 1. Hundreds is 2. That should be very easy to remember. The number following the decimal is based on the actual number that we have. So for 4 million, we get a decimal part of 602. All right? So the 0.602 tells us it's a 4. The 6 in front tells us that we're in the millions. You should be able to work in either direction, and we practiced that skill last time. Okay, so for log identities, there's 3 of them. The first log identity I want to prove to you is that if you have 2 numbers that are multiplied together, and you took the log of that, you would get the same answer as if you added the log of the 2 individual numbers. So what this does for us, if we're multiplying numbers that are really big, and believe it or not, there are some numbers that won't work on the calculator because they're just too big. We can deal with those numbers by taking the logs of them and adding them together, and then using that to figure out what we would have gotten if we could have just multiplied them. Before the calculator was invented, this was an incredibly useful technique. Now it's just occasionally useful, but let's prove that it is correct. So let's think of 3,000 as 2 numbers multiplied together. And for ease, let's just look at it as 3 times 1,000. So according to our identity, if we take the log of 3 and add it to the log of 1,000, we should get the same answer as just taking the log of 3,000 to start with. So the log of 3 is 0.477. The log of 1,000 is 3 because we got 3 zeros. So the log of 3,000 should be 477, 3.477. And you should be able to do that like I taught you last time, and it should match up. Or you can do it on your calculator, and it should match up. So our rule seems to work. We probably didn't need the rule, but we would need it when we have a number like this, because we can't just do that in our head. But if we think of it as 3 times 0.01, we can now deal with this quite easily. So that should give us the same answer as if we did the log of the 2 separate numbers that we're going to multiply together and just add those 2 logs. So log of 3 and the log of 0.01 we learned was -2. So now when we put this together, we get -1.523. That is something that you probably would not have been able to do from just looking at our charts. But if you put that into your calculator, you should verify that our identity did indeed give us the right answer. So box him off and make sure you understand the importance of this. It allows us to do a simpler mathematical operation, that is addition, and get the same value we would have gotten if we had done a multiplication. So we have simplified the process that we need to do. Okay, the second log identity is a direct offshoot of that. So we just saw if we have A times B, it's going to be log of A plus the log of B. Well, what if our thing is a perfect square? So we have log of, instead of A and B, we can think of that as 7 times 7, so both numbers are the same value. So that would be log of A plus the log of A. And that can be simplified to just 2 times the log of A. So for numbers that are squared, we can just find the log of the simple number and double it, and we'll have our answer. And this doesn't just work for squares, it works for any power. So if we have a raised to any power, that'll be the same as the power multiplied by the log of a. And powers can be extremely hard to calculate by hand, and this makes the process much easier. Okay, back before calculators, it was a lifesaver, and now it's occasional necessity when the numbers are too big for our calculator to handle. All right, so let's try it. I hope you see that log of 49 is the same as log of 7 squared. So if you look at the log of 7 and double it, zero, 9, 6, 1. Again, we were able to figure that out without a calculator just by using our rule. This is going to be the same thing but for 8, so we would take that and double it, and we get 1.806. We can do these lightning quick. All right, so that is our second identity. One more time, I'm going to rewrite it because I erased it. Log of a to the b is the same as b times the log of a. It simplifies what would have been a very hard process, especially when this b value becomes larger and larger numbers. Okay, so I'd like you to try these two. So for the first one, think of it as log of 7 times 5. Log 7 plus log 5. Try not to use your calculator. Try to use our log tables here. And for this bottom one, think of it as 9 squared. So that should just be 2 times the log of 9. All right, so give it a shot. They shouldn't take long. Verify then on your calculator that our two identities that we learned already work out beautifully. The third and final identity, I think you could guess at this point. It's when you have two numbers that are divided by each other, so a divided by b, and hopefully you can make the jump that with division, it's going to turn into a subtraction of logs. So then you have to just imagine a series of numbers that could give us our number that we're trying to evaluate. So the log of 0.25 would be the same as the log of 1/4. So that becomes the log of 1 minus the log of 4. Log of 1 is 0, log of 4 is 0.602, and just that quick, we've got our answer. This one's a little hard to envision, but we can have that as 1,000 divided by 8. Log of 1,000 minus the log of 8. 3 minus 0.903. 2.097. Okay, you want to check it on your calculator? Log 1.25, 2.097. Boom. Okay, so again, we haven't really saw how these are going to apply yet to our decibels, but I hope you understand the three different identities, and I hope you get the idea that it takes hard mathematical operations and turns them into simpler mathematical operations. Multiplication becomes addition, powers become multiplication, and divisions become subtractions. Okay, so see if you can do these three, which would be really hard to do without a calculator, and try not to use your calculator. Just use the rules that we had in our simple log table and see if you could evaluate what we get for each of those three expressions. A power, and a division. All right? Tomorrow, I'll show you how we could do more accurate math, and I'll show you how we use logarithms for graphs. Following that, we will go in and actually look at decibels and how we use logs to help us interpret the intensity of sound.